This is the PowerPoint for 5.1 basic probabilities. And I'm going to go over part of the worksheet as we go through this. But there are three basic types of probabilities. You have empirical, classical, and subjective. Empirical is based on results from actual experiments, and classical is, or theoretical, is based on an ideal sample space where all outcomes are known. And then subjective is just an educated guess. You have a range of possibilities anywhere from 0 to 1 or from 0% to 100%. 0% it never occurs, and 100% it occurs. It must occur. Probability of 0.5 or 50% would be right in the middle, and just as likely as to happen as it is not to happen. If it's less than 0.5, or sorry, less than 5%, or that's not what was supposed to happen. If it's less than 5%, then it is considered unusual. Empirical probability is the ratio of desired outcomes to the number of experiments. So, example, the results of rolling 10 die is the number of observations of event A occurring and the number of over the number of experiments. After 3 rolls, the results of rolling 10 dice the probability of a 1 is 1 out of 3. Probability of a 2, there's not a 2, so that's a 0 out of 3% chance. And then the probability of rolling a 6 is 0 out of 3% chance. After 10 rolls, then you've got, of rolling a 1, you have 1 in 10 chances. Rolling a 2, you have 3 out of 10 chances. And a 6, you have 0 out of 10 chances. So the empirical, or the relative frequency probabilities, can change as the number of experiments change. So this is a note that says, let's go back to that. The probability of A equaling 0 means the event has not yet occurred, not that it cannot ever occur. So classical probabilities are found by examining the sample space for a particular event. And the sample space is the list of all possible outcomes for an event. The number of occurrences of event A is the size of the sample space.
We expect it to be rigid. We expect it to be flat. We expect it to be fragile. But what if it wasn't? Wouldn't that
So the sample space of rolling a die is 1, 2, 3, 4, 5, and 6. And the probability of a 2 is 1 out of 6. The probability of a 1 is 1 out of 6. The probability of a 6 is 1 out of 6. The classical probabilities do not change as the number of experiments change. Using your knowledge, you assign a chance of occurrence. The probability that the USA will get the most medals in the 2012 Olympics: 10%, 40%, 80%, 95%. Probability you pass this course: 95%. complements and odds. The complement is the opposite of an event denoted by a bar on top of the A. And odds in favor is P of A, and failure is P of complement of A. So given a standard die, then the odds of getting a 3 are 1 in 6. The odds of not getting a 3 is 5 in 6. So that would be 1 out of 5 would be the chances of getting a 3. There's 1 3 and there's 5 not 3s. Given a standard deck of cards, then what are the odds of getting a heart? Well, you've got 13 chances of getting a heart, and you have 39 chances that it's not going to be a heart. So that would be a 1 in 3 odds. So the probability of not E is the probability of an event not occurring. So the probability of the complement of E is the failures over the total. The odds of not E is the odds of E complement is the failures, the ratio of the failures and the successes. So a 6-sided die, coin, and a coin. So if you've got 6 sided die for 1, if you roll the die and you get a 1, then you've got a chance of heads and a tails when you flip the coin. A 2, then you've got a heads and a tails to flip the coin. Selecting 2 colors from red, green, blue, and orange. The tree diagram, if you draw red, and then you could get a green, and then a blue, and then or an orange. You could draw a green and a red, and then a green and a blue, and then a green and an orange, and so on and so forth. Law of large numbers tells us that the empirical probabilities become the same as classical probabilities after a large number of trials. If you flip a coin 3 times, then the probability of getting a heads is 2 out of 3, which is 66.7%. If you've flipped the coin 300 times, then the probability rises to 51%, which the classical classical probability would be 50%. You've got a 50% chance of getting a head and a 50% chance of getting a tails. So, if you do enough experiments, then the empirical probabilities will match the classical expectations. And that's just what the law of large number is. Oh.